All right, next few. We've got 8 to the n times 3 to the n divided by 4 to the nth power. So remember, if we have the same exponent, we can go ahead and multiply these together. So I have really 24 to the nth, oops, not 24 squared, I have a 24 to the nth power divided by 4 to the nth power, and that will simplify out to, what is that, 24 divided by 4, 6 to the nth power. All right, h is pretty tricky. Let's kind of slow things down a little bit here. One way to think about it would be to just work right through your order of operations, meaning you've got parentheses. Let's do the stuff in parentheses first. So that gives us, make a little wall here, that gives us 1 over a plus 1 over a squared, all to the negative 1 power. And now even here with these, we can't, the exponents doesn't distribute across addition, so don't be tempted into just writing that this is a plus a squared, because it's not. So let's kind of simplify here in these parentheses, and let's try to get a common denominator. So if I want to have a common denominator of a squared, I'm going to need to multiply this first one by a over a, and that's just 1. So I'm not really changing the value, just changing the way that it looks. All right, that gives us, I don't need that much room, and that gives us a over a squared plus 1 over a squared to the negative 1, which we can rewrite as a plus 1 over a squared. And now we've got just one fraction. We can use our negative exponent now, and our final result will end up being a squared. So everything's going to switch upside down here in our one fraction. So a squared over a plus 1. All right, there's our answer. And off to the side over here, we'll do another way. And what if we had done our exponents first? So we have these exponent rules. Let's try using them. So a to the negative 1 plus a to the negative 2, and then that quantity to the negative 1. So if we had used our exponents first, we can see that we're going to need to, or we can't use our exponents first, we're going to need to get a common denominator in here from right from the get-go, because we want to get to one fraction so that we can use our common denominator. Meaning we're going to need to multiply everything by a squared over a squared. So a squared over a squared. And that should be inside the parentheses there. So that gives us a over a squared plus 1 over a squared. And that's all to the negative 1 still. And that can simplify it down to, got our common denominator now, so we can add that up. We have a plus 1 over a squared, all to the negative 1, and we again get a squared over a plus 1. And that might not be quite as clear, and so I'd kind of recommend using that first way of just really going right through your order of operations, but just want to point out that it is another possibility for you. Actually, we don't need to delete that. So then I is our last one here. We've got option 1 would be just going right through your order of operations. So this is a to the negative 1 times a to the negative 2, and that's going to be a to the negative 3. Now that to the negative 1 power gives you a to the positive 3. That's option 1 of just using your order of operations, just going right through it. However, we can also apply our exponent rules. So if we redid this one here as a to the negative 1 times a to the negative 2, and that all to the negative 1, we can use our exponent since this is being multiplied. And so this would be a to the positive 1 times a to the positive 2, which again gives us a to the third power. All right, hope that helps.